Out, 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 foul mandrill. Oh, donkey for 3. Oh, it's no good. Hello Internet, my name is Quinn and this is Blondie Hacks. Do you ever wonder, with all these projects that people make on YouTube, the tools and the furniture and everything else, after they make the thing, usually hastily, and then take the pretty pictures of it for the thumbnail, do they actually use that thing? Do they still use it a year later, 2 years later, 5 years later? Is the design really as perfect that first time as it appeared? Well, I'm going to dig into that for all of my projects that I've done over the years, and I'm going to tell you the rest of the story. First up is this cheerful little fellow. This is probably new to almost all of you currently watching because it was a very, very early project on my channel. This is a universal smartphone holder for tripod mounts. And I thought it was a really neat project that deserved a little more traction than it got in the algorithm, but I'll link to it below so you can watch it if you like. And this thing has worked out extremely well. So well, in fact, that I made a second one, and I use them both pretty heavily for shooting on my channel. I mostly shoot on a DSLR these days, but I still use smartphones for the slow-mo footage and working in tight spaces and some of the other tricky shots. So the way it works is very simple. You can put any smartphone in there like so, and it's just spring-loaded, and then with the rubber grip, it'll hold any smartphone in any orientation. So it's very universal in that way. And it works extremely well. So if you're interested in something like this, go check out that video. Next up is my custom grinder rest. This was a 4-part series about 2 years ago on the channel. And this thing has worked out pretty well. There's been some strong successes and some weaknesses in this design. The aluminum platen here has worked out really well. I did take some heat at the time for using aluminum. People felt that wasn't a good choice for a grinder rest, but it's held up extremely well. I've had no issues with it. Maybe aluminum wouldn't be a good choice in a production shop where it's going to be getting, use hours and hours a day, but I mean, I've used it heavily for 2 years and it's holding up great. The two main weaknesses of my design are here in the adjustments. The angle adjustment really should be some sort of a lever action, like a kip handle, something like that. And people at the time did recommend that, and I should have listened. Alternatively, some sort of arc with a slot in it would also work. The point of either of those solutions is to give you more leverage on the joint here, because it's difficult to get a single knob like that at the pivot point tight enough to hold it so that it doesn't move under forces of grinding. My solution has been that I use small channel locks to tighten that knob, and it works fine. I don't really ever adjust the angle. I just leave it at 10 degrees because that's what I use for grinding tool bits. But yeah, that's definitely an aspect that should have been better. But the biggest area of problems has really been the lateral adjustment. You can see that I put these slots in here to give it a lot of lateral adjustment, but I gave it tons of adjustment outwards and not nearly enough adjustment inwards. And inwards is where you need the adjustment, because the two things that happen with a grinder rest are the wheel wears down and you want to angle the table away from the wheel. Both of those things require inward adjustment. The outward adjustment is essentially useless. And you can see I've completely used up all the inward adjustment, and I've already rearranged things a little bit here to increase the size of these slots a little bit, but I've completely run out of space here. What I ended up actually doing was moving the pivot point on the table further outboard to give me more adjustment effectively in that direction, which is not the best solution because part of the design here is that the pivot point is supposed to be in line with the front edge of the wheel, so that as you tilt the table, the grinding area remains on the center line of the wheel. So that aspect here is a little bit broken by the fact that I've moved the pivot, but it was really the only way I could get more inward travel out of the design here. One other aspect that I don't remember if this made it into the video series or not, but I had to add this stiffening bracket down here. This is actually the second version of this bracket. The first one was a bent piece, and then I later created this welded multi-segment piece to give myself more clearance for the lateral adjustment here. This was really necessary because I mounted the entire grinder rest to the factory dust shield, which is how the factory one was mounted, but now I'm asking a lot more of it because I've got more mass and more angle adjustment and so on, and so it was very prone to vibration. When the machine is running, the whole table would vibrate a little bit, which was super annoying. So this stiffener brace here took all of that out. A better design would be probably to mount the grinder rest to the base or to the bench underneath the grinder, something like that. My grinder is mounted on a mobile stand, so everything has to move with the grinder. It's part of the limitations of my shop here, the space that I have. But this solution here has solved the vibration problem. One other key design feature here was this miter slot, which at the time I thought was pretty clever, and I made this little miter gauge that fits in there that can hold the tool bit that you're grinding at the exact right angle. And honestly, I used this maybe twice and then never again. The fact is, after a little bit of practice, you get very good at holding a tool bit at a particular angle, and you can grind to a scribe line really quite accurately, and this just didn't end up being very useful. Overall though, I'm very happy with this modification to my grinder. I definitely recommend doing something with your factory grinder rests because they are the chief weakness on these big box store grade bench grinders. This makes it infinitely more useful to a hobby machinist. Next up is one of my favorite projects that I've done on the channel, these Toolmakers clamps. You see me use these a lot on the channel, so it would seem like they were an unmitigated success. Well, not quite. I've definitely had some issues with these. First and foremost, you may recall if you watched the video series on these that I made what I called Type 2 clamps, where both sides are threaded rather than the back being threaded into a blind hole and just acting as a smooth pivot back here. I did that at the time to recover from a mistake because I had drilled out this jaw and I shouldn't have, and I didn't want to remake the parts. And they work fine. However, I do think that the so-called Type 1 clamps are probably easier to set up and use. These clamps are a little bit fussy to open and close the jaws because you have to thread and unthread both of them at the same rate or the jaws will bind up on you. And people are constantly telling me, you know, you can just flip them around like this to quickly open and close them. No, you can't. This will actually bind up if you do that, because in order to do the flippy motion style of clamp opening, the rear screw has to be a left-hand thread. And so that's another change that if you want to do this style of clamp is worth considering, is to make the rear a left-hand thread. Those are all fairly minor quibbles. The main issue that I had with these that I had to actually repair was in this area here. In the original design, there's a very fine slot cut in the shaft there, and then I had E-clips in here to retain that. And when I was designing that, I was mainly thinking that that E-clip's job is primarily to just keep this rear portion of the lead screw in place. However, when you're clamping down on these, a lot of the time what you do is you jack up the rear after you've set the front to tighten the front. That turns out to be one of the easiest ways to get the jaws tight, is to just set the front and then jack up the rear, as it were. When you do that, however, it puts all of the clamping pressure right here on this E-clip. And what happened was, after about a year of use, those E-clips started to bend and eventually they started to pop out. And I replaced them a couple of times, but then they started to chew up that little slot. Now the slot held up fairly well because these are tool steel, but it is a very tiny slot with a fair amount of clamping force on it, and eventually the slot got too chewed up and the clips were popping off all the time and the clamps became useless. What I ended up doing was removing the clips, and right about where the slots are, I drilled and reamed a 1/16 hole through in the same spot there, and I put tiny little 1/16 roll pins in there. Roll pins are spring steel, so they're very strong, and they go all the way through, so there's lots of strength there when that clamping force is applied. That clamping force is applied to the entire width of the shaft there instead of just the outer surface of it. And being a tiny 1/16 pin, it's still within the clearance area that I had cut for the E-clip, so the clamps will still close all the way flush. This little modification has been a big win. The clamps are much stronger and much easier to use now, so they will serve me well, I think, now for many more years. Next up are my machinist jacks. Sometimes mistakes that you made are a lot less serious than they seem like at the time. If you watched the video series on making these, you know that this is the project where I learned that The angle markings on import lathes are 90 degrees off on the compound from where they are on American and British lathes. So I actually ended up cutting a sawtooth thread on these rather than a proper 60-degree thread. And the effect of that is that as you get towards the end here, these things are pretty sloppy in there. You can see how much motion there is. However, this turns out not to matter at all in practical use. As you can see, the thread still works just fine despite being the incorrect thread form and despite being poorly made. But the thing is, when you're jacking them up underneath a part, once the pressure is on them, it doesn't matter anymore. I was sure at the time that I would end up remaking these because the sloppy and poorly made threads would surely doom them to uselessness in the real world. But the fact is, you've seen me use them thousands of times on my channel and they work just fine. I've had no incentive to remake them at all despite all the issues with them. So it just goes to show that as a beginner, you shouldn't be afraid to try making your own tooling like this, because even if you make it poorly because you're a beginner, that's okay. You learned a lot and there's a good chance that the final tool will still be perfectly usable. Next up is my corner rounding fixture. This was a relatively recent tool making project and I have big plans for this. I'm actually going to be building some things that are going to require a lot of corner and end rounded parts like I showed when I made this. I've used it a little bit since then, like you saw me use it on the float lock vise and it worked super well there. So the jury is still out on this. It's working fairly well. It's not quite the magic bullet solution that I had hoped for, but so far so good is what I'm going to say about this. The one big weakness that it has that I have identified so far is the centering mandrel here in the middle of the rotary table. This would really benefit from a drawbar thread in the back so that I can clamp it from behind in the rotary table. The Morse taper is very secure, but it is possible to get carried away when using this center clamping position here. And if you tighten the bolt too far down, what happens is that bolt effectively applies lifting forces on this taper because you're clamping against the top surface of the table with the part. And it is possible to jack this right out of there. And this can be easy to do by accident, and you may not notice until the milling cutter touches the part. So a little security with a drawbar thread on the back would be a good idea. I haven't figured out how I would do that yet. There isn't really space on the back of the rotary table to do that easily, but I think it's a solvable problem, so I may make that improvement at some point. Remember this giant project from recently? This is my material storage rack that's stuffed way over here in this dark corner of my shop. And generally, this has worked out extremely well. I have to say it really solved all of my material storage problems. However, it's not perfect. The most glaring issue, and the thing that I will be taking steps to solve at some point, is I didn't really account for how I'm going to get stuff in and out of these bins. When they're all lined up like this, it's all looks very nice and everything's stored very well. But when I go to fetch a piece of scrap out of here, some of these bins are quite heavy. Like this is the small mild steel bin, and it's quite heavy. And now what? There's nowhere to put it, right? So I end up sitting on the floor in the dark fishing through these bins, and then I gotta put the lid back on and slide it back in. What's really needed here is some kind of little table that you can set the bin on to dig through it. So I'm thinking maybe some kind of a fold up or a slide out, something or other, something in the middle maybe, so that no matter which bin I'm in, I can easily set it down somewhere and dig through it and put it back. That would be a big quality of life improvement here. That and improving the lighting over here. The second issue that is kind of a funny one that I really didn't think of is I've got this range of sizes of bins here, right? The idea was that I have space for small, medium, and large pieces of stock of various alloys. And then I've also got these tubes here on the sides for storing large pieces of bar stock. What I really should have done though is worked out the difference in length between what the tubes can hold and what the smallest bin can hold. Because what I've found is that there is a particular size of bar stock that gets too short to be held in these tubes. It'll fall out the bottom, but it's still too long to go in any of my bins. So I have this kind of no man's land of stock that's sort of scattered around in the area here because it doesn't fit in any of these places. Or frequently, I'll end up just cutting a piece of scrap in half so that it'll fit in the bins, things like that. What I may end up doing is adding an additional tube partway down over here so that shorter stock will still fit in here, or something along those lines. So it's a funny problem. If you're going to design a material storage solution, you want to consider that you want to have overlap in length capacity of all the different storage areas, or else you may find yourself with nowhere to put a certain sized piece. Another change I've made here since this video is to add these additional rings at the bottoms. A number of viewers suggested this to kind of help corral the bottoms of the bar stock, and this really is a good idea. Even when the rack isn't moving and you're not looking at it, somehow in the night the bottoms of these bars migrate their way off and end up falling on the floor or otherwise getting into disarray here. So I've done it with the larger sections. I'm waiting for McMaster to send me another one of those small tubes so I can do the small tubes out here. But this has been definitely a real win, so I recommend adding that to the design if you're going to do something similar. Last up is my most recent tool making project as of this recording. That's these dedicated faceplate clamps. Now the idea with these is that every element of the clamp is captive, so they act like a regular heel-toe style strap clamp, except that there's nothing loose, nothing held in by friction alone, so you can spin them up with confidence on a faceplate. These have worked out extremely well. As of this recording, I've used them exactly twice, but they've been an outstanding success for those two cases. However, as I was making them, one of my very clever patrons suggested, you should make little brass caps to go on the bottoms of the rear jack screws so they don't mar up whatever you're clamping against, typically in this case the faceplate. And I agreed that did sound like a great idea. However, I was kind of in a hurry to get going with the project I was making these for, so I ignored that inner voice telling me that I should really do that. And predictably enough, they did in fact mar up the faceplate here. It's not a big deal, they're stone smooth, it's just a cosmetic thing, but I think I probably will end up making little pads for those screws so that this doesn't just keep happening. The takeaway here is always listen to your patrons. All that was a very long-winded way of saying that tools and products are very much an iterative design process, and you never get it right the first time. But don't let that stop you from designing and building your own tools or furniture or whatever you're interested in. Even if it's not perfect, it's still probably going to be great, and you can always modify things later, as you've seen in many of my tool designs here. Well, I hope this inspires you to go build something in your shop. Thank you very much for watching. Thanks especially to my patrons who make all of this content possible, and I will see you next time.